SV Math Teacher here, reminding you to like and subscribe if you enjoy these free videos. Today's video is on functions. Now the last video is pretty lengthy. This one can be quite a bit shorter. Functions, when we specifically talk about graphing, oh my gosh, it becomes so nice. Because all we really have to do is study what a graph looks like and then potentially learn this one new thing. It's called the vertical line test. Very, very simple. I'm going to teach you how to do this today. So check it out. First up, all data that has two pieces of information, we might refer to that as bivariate data. Any data creates a relation. Okay, so every relation everything we're talking about is a relation. Well, it might also be a relation and a function. We're really going to focus over here, right, for this video. So the data that becomes a function. Well, what kind of function? It could be a linear function where the data increases or decreases at a consistent rate, or a nonlinear function where it doesn't. It might curve or flex or whatever. So let's go ahead and talk about relations and functions. And in the graphical form, this is what we have to look at. Now here are just 6 examples. We could have 50 examples, but we'd be here all day. So 6 examples. Here's what I observe right off the bat. I'm just going to use a highlighter tool because I don't want to draw on these too much. But I observe that right away, I have a number of these that do not appear to be straight lines. Now some of them are made up of like portions of straight lines, but 5 out of the 6 of these are non-linear because they're not made of straight lines. So I'm going to go ahead and say that this one right here is the only linear graph because it's the only one that has a straight line that's not broken up into other smaller chunks of straight lines, or it doesn't double back on itself or form a W or a V or something like that. All right? Now, that doesn't mean, however, that each one of these things is a function. Remember, data can create a graph, and that graph could be a relation only, or it could be a function. If it's a function, it can be linear or nonlinear. So let's look at these a little bit more closely. I'm going to go ahead and say that this one right here is not a function. In fact, if you were on with the last video, I would have probably used red for this because red was the not a function stuff. And I'm going to go ahead and choose one more that's not a function, and then I'm going to show you why. This is not a function either. The other ones are all going to be functions, and since we've established that the bottom left is the only linear, then they're all going to be non-linear functions. So let's go ahead and clarify. This is non-linear function. We could go ahead and say it's a relation only, but if we say it's a function, it has to be a relation as well. So let's see if it'll let me do this. Here we go. And nonlinear function down here as well. So we have 3 nonlinear functions. We have 1 linear function. And then we have the 2 that are not a function. So the mystery becomes, well, how do I know those red ones? How do I know they're not functions? And that brings us to this thing called the vertical line test. So let me show you. I have the image with no writing on them down here. I'm going to create a vertical line. Now, the iPad will probably let me snap it straight, and that looks like it's pretty straight. What I'm going to do is I'm going to drag this vertical line across my graph. Now, the advantage in dragging it across my graph, I'm going to zoom in for a second. When I drag it across the graph, it can only touch one of the x values at a time. This really overly enthusiastic highlighter tool. But it can only touch one thing at a time. Oops. So let's look for opportunities where it does that. Look, so when x equals 1, y equals 6. When x equals 2, y equals 5. When x equals 3, y doesn't exist, so we wouldn't really include that. When x is 4, y is 6. When x is 5, y is 5, and so on and so on. Do you notice how each of the x's, or input values, this is your input, each of the inputs have exactly one output. That makes it a function. So this is a function, right? And that's why we wrote that in the previous screen. Let's look over here. As we go across, when x is, let's say, 0.1, y is a little more than 2. When x is half, looks like y is about 2.5. When x is 1, y is about 3, and so on and so on and so on and so on and so on. Now we get to this flat phase here, right? This flat phase up here. Well, even though it's flat, as I move my blue line, if I can find it, even though as I move my blue line 4, 4.1, 4.2, 4.5, and so on, the x value keeps changing. Now the y value stays the same, but that's okay. Each x value only has one y value, so this is considered a function as well. But look over here. As soon as I move off of the original origin, I wouldn't even really have to move off the origin, to be honest, but I'll do it anyway because it'll be more obvious. Look what happens when x equals 1. I have two different y values. That breaks the function rule. That automatically makes it not a function. And if I drag it over to another spot, there it is again, and again, and again, and again, and again, and again. And if it happens even one time where I have this vertical stacking is what I refer to it as. If I have this vertical stacking of points where when x equals 1, I have two different y values. In this example, probably something like 1/2 and something like 6.5. So one matches up with two different things. That is against the rules as far as functions. So this is not a function. And that's what the vertical line test is. Right, here comes the vertical line again. Let's drag it across those bottom ones. Oops. Let's drag it on those bottom ones and see if we can check it out again. Here we go. Maybe not. Finally, okay. I drag it across. Notice how it's only ever touching the purple line at one point. That makes that a function. Notice how here, it's only ever touching the purple line at 1 point, 1 point, 1 point, 1 point, 1 point, and then 2 points. That fails the vertical line test, so this is not a function. And then look at this. Now it's touching at 3 points. If you're not clear on what the 3 points are, those 3 points are this one, and this one, right? So that's like a triple failure. So that's really, really bad news for us. Definitely not a function. And then I check out the last one. This passes. So not linear, but it's a function all day long. So that should explain how to use the vertical line test to identify what is and is not a function. Once again, look for that vertical stacking, and when you see it, that means not a function.